Hi, welcome back to Science 1206, the Chemical Reactions Unit. I'm Ms. Ledwell, and in this video we'll talk about single replacement, double replacement, and combustion reactions. Let's get started. First, we'll talk about single replacement reactions. A single replacement reaction is a chemical reaction where one element takes the place of another element in a compound. The general formula for single displacement reactions is A plus BC produces AC plus B. Notice that the A and the B switch places. An example of a single replacement reaction is iron plus copper 2 sulfate produces copper plus iron 2 sulfate. Notice that the copper and the iron have switched places. In single replacement reactions, the element reacting can be a metal or a nonmetal, but a metal always replaces a metal, and a nonmetal always replaces a nonmetal. For example, if we have copper plus silver nitrate, it yields silver plus copper 1 nitrate. We have the metal silver replaced by the metal copper. In our next example, we have sodium bromide plus chlorine produces sodium chloride plus bromine. We have bromide, the nonmetal, replaced by chloride, the nonmetal. So again, a metal always replaces a metal, and a nonmetal always replaces a nonmetal. Next, we'll look at double replacement reactions. In double replacement reactions, the positive ions of two different compounds exchange places, forming two new compounds. The general formula for double replacement reactions is AY plus BX produces AX plus BY. For example, we have sodium hydroxide plus copper 2 sulfate produces copper 2 hydroxide plus sodium sulfate. Notice that the sodium and the copper have switched places, and we have two new compounds formed. Some examples of double replacement reactions include silver nitrate plus sodium chloride produces silver chloride plus sodium nitrate. So here the silver and sodium switch places, producing two new compounds. Sodium carbonate plus calcium chloride produces calcium carbonate plus sodium chloride. Here the sodium and the calcium switch places, producing two new compounds. And our last example is potassium iodide plus lead 2 nitrate produces potassium nitrate plus lead 2 iodide. So here the potassium and lead have switched places, producing two new compounds. The last type of reaction we'll talk about are combustion reactions. A combustion reaction is a chemical reaction in which an element or compound reacts with oxygen to form compounds called oxides. Energy in the form of heat and light is usually released in a combustion reaction. Burning fuels such as wood, propane, or gasoline involves combustion reactions. Many combustion reactions involve hydrocarbons. Hydrocarbons are compounds that contain only hydrogen and carbon atoms. Examples include propane, C3H8, and candle wax, C25H52. A general equation for the complete combustion of a hydrocarbon is a hydrocarbon plus oxygen produces carbon dioxide gas plus water. For example, the balanced chemical equation for the complete combustion of methane, a natural gas, is we have methane CH4 gas plus 2 oxygen gas gives us carbon dioxide plus 2 water. Carbon monoxide and soot, which is carbon in a different form, are produced when incomplete combustion occurs. This process often leads to the emission of an orange smoky flame. When balancing combustion reactions, balance the elements in the order carbons first, hydrogens next, and oxygens last. Let's look at this example. So on our reactant side, we have 5 carbons, 12 hydrogens, and 2 oxygens. On our product side, we have 1 carbon, 2 hydrogen, and 3 oxygen. We need to balance our carbons first. So we have 5 carbons on the reactant side and 1 on the product side. So we need to put a coefficient of 5 in front of carbon dioxide in order to get 5 carbon. The next thing we need to balance are our hydrogens. So if we check, we notice we have 12 hydrogens on the reactant side, but only 2 on the product side. If we put the coefficient 6 in front of water, 2 times 6 is 12. That'll give us 12 hydrogen. Our number of oxygen has changed. We now have on the product side 10 from the carbon dioxide and 6 from the hydrogen. That's 16 oxygen. So what number can we put in front of the oxygen on the reactant side to make 16? That would be an 8. 8 times 2 gives us 16. So now we need to double check that this is balanced. We have 5 carbon on the reactant side and 5 on the product. We have 12 hydrogen on the reactant side and 12 on the product. We have 16 oxygen on the reactant side and 16 on the product side. So our equation is balanced. Notice that the space in front of C5H12, which is pentane, is left blank. That's because we don't need to add a coefficient here in order to balance it. When there's no coefficient in front of a formula, it's assumed to be 1. Next, we'll look at some hints for figuring out what type of reaction you have. Some questions to ask yourself when identifying the type of reaction are compounds being combined or broken apart? If they're being broken apart, it's a decomposition reaction. Are the reactants elements and the product a single compound? If that's the case, it's a formation reaction. Does the equation have the form hydrocarbon plus oxygen produces carbon dioxide plus water? If it does, it's a combustion reaction. Does the reaction have 2 compounds reacting to form 2 new compounds? If it does, it's double replacement reaction. Is 1 element and 1 compound reacting to form 1 new element and 1 new compound? In that case, we have a single replacement reaction. Now it's time for you to do some practice identifying the types of reactions. Pause this video and grab a pencil and some paper. Number your paper from 1 to 7. As each description or equation in the table on the next slide is revealed, record the type of reaction. We will then review the correct answers one by one. Good luck, and after numbering your paper, please resume this instructional video. Now it's time to do our practice. Our first chemical reaction is silver nitrate plus sodium chloride produces silver chloride plus sodium nitrate. What type of chemical reaction is this? This is a double replacement reaction. We have 2 compounds as reactants and 2 compounds as products, and the silver and sodium have switched places. That's our key things that tells us that this is double replacement. Our next reaction is iron plus sulfur produces iron 2 sulfide. And this is formation. We know this because we have an element plus an element producing a compound, and that's the key to identifying formation reaction. Next, we have potassium chlorate becoming potassium chloride plus oxygen. What type of reaction is this? This is decomposition. We have a compound breaking down into simpler substances. Our next reaction is iron plus copper 2 sulfate becomes iron 2 sulfate plus copper. This is a single replacement reaction. Some of the key things that tell us that are we have an element plus a compound producing an element and a compound, and the iron and the copper have switched places. Next, we have a description of a reaction. Solid calcium carbonate decomposes into solid calcium oxide and carbon dioxide gas. This is a decomposition reaction. The word decompose in this description is actually a key thing that tells us it's a decomposition reaction. Other signs are we have a compound breaking down into simpler substances. Next, we have a word equation. Aluminum plus copper 2 chloride produces aluminum chloride plus copper. This is single replacement. We have an element plus a compound producing a compound and an element. And we have a switching of places, our aluminum and copper. Last, we have methane plus oxygen produces carbon dioxide plus water. and this one is combustion. The key things that tells us that this is combustion are we have a hydrocarbon plus oxygen as our reactants, and we have carbon dioxide and water as our products. Now it's time to review. Please complete the learning activities you'll find in Brightspace.